In today's video, I shall be making this lathe centre height gauge from Hemingway Kits. I'll take you through how to make it, how to set it up, and later in the video also how you might be able to win it. I'm going to be giving this away to a subscriber, so stay tuned for that. The first job is to machine the base of the tool from this casting that comes with the kit. Now it's a nice casting, but like all castings, it's kind of rough and out of shape, so the first job is to get it running as true as we can in the 4-jaw chuck. I've faced off the end of the part and I'm centre drilling it here now because we're going to be doing some fairly heavy turning on this, and I'd like to bring in some tailstock support. Now we're going to face off the top of the base, and there is that fillet in the corner there. I'm going to turn this into a little decorative boss, I think, but you could just machine it away if you prefer. Now the plans call for this cylindrical portion to be 1 inch in diameter, or just over 25 millimeters. Now this isn't a critical dimension, it's just cosmetic really, but I think it's always fun to try and shoot for precision wherever you can, and I've managed to hit that one pretty much on the nose. And another optional little decorative feature here, I'm just putting a radius on that boss with a round nose form tool. I'm not super happy with the finish I'm getting with this insert that I'm using on cast iron, so I'm just going to come in with some Scotch-Brite here and try and clean that up a little bit, just make it a little bit more presentable. So that's one side of the part complete, and now we need to flip it round and machine the other side. And I've left quite a lot of stick out there because we are going to need to part this off once the machining is complete, and I need enough room to get the parting tool in. So I'm bringing this base to dimension. I'm going to be machining the thickness to 9/16 or just over 14 mil, and the diameter to 2.5 inches or about 64 millimeters. And we'll finish that off with a nice chamfer on each side. So the next couple of features that we're going to make here are reasonably simple, but they are probably some of the most important of the entire project. Now they're going to be the bore and the recess that we're going to machine in for the post shaft and the post boss. And if this tool is going to be in any way accurate, it's really important that these two features are dead square to the bottom of the base. And of course the way that we make sure that they are square to the bottom of the base is by machining them in the same setup. Now I'm going to drill and ream this to 7/16, which is just over 11 millimeters. And for this build, I'm going to stick to the imperial measurements. Normally I work in metric, and there's no reason why you couldn't convert these dimensions to metric to, you could drill and ream it to 11 or even 12 millimeters, and it would be absolutely fine. You just have to make the boss, which we're going to make later, to the same dimensions, obviously. And here I'm going to bore out the recess and the shoulder for the boss. And we're boring this to a depth of 3/16, which is just under 5 millimeters, and to a diameter of 13/16, which is just over 20 millimeters. Time for parting off now. I'm parting it off a bit long. It's supposed to be 1 inch in height, just over 25 millimeters, including that raised boss piece. But yeah, I'm parting it off a bit long, just so I can get the tool in for a start. But I also want to be able to flip the part round and clean up the top of that boss. Just measuring the part now so that I know how much I need to take off. I've plumbed that dimension into the DRO, and we're going to reduce the overall height of the base to exactly 1 inch or 25.4 millimeters. We need a bit more clearance on the base of the height gauge so that when in use we can bring it in closer to the tool post. And in order to do that, we're going to machine a flat on one side of the base. A very simple setup here. I'm just using a 16mm end mill, which is about 5/8, and I've simply clamped the part in the vise, and we're just going to mill down to near enough where that kind of decorative boss feature starts. I really enjoy working with cast iron, but there is no denying that it is a messy material. And to state the obvious, if these iron filings get into your slideways, then it's bad news for your machines. So that's all the machining done on the base, but before we move on, I'd like to just manually put in some chamfers with the file to blend those newly cut edges in with the chamfers that we've already put on in the lathe. So this is where we've ended up, and that's the base now complete. So let's move on to creating the locking nuts, which will secure the post and the boss to the base. We'll be making this out of bar stock, which you get included with the kit, and we're going to be machining it to, in this case, 1 inch or 25.4 millimeters, or whatever you chose to make the boss on the base. You could change up the dimensions. It's not critical. I chose in this case to do the knurling before the turning so that I can turn right up to it and get a nice clean edge. Now I'm going to drill and tap this 7/16 by 32 as per the plans. If you wanted to convert this to metric, you could probably use an M12, I would think. You'd have to make the boss a little bit wider, but I'm sure that would work, although you might want to use a fine pitch rather than a coarse pitch. Now I'm going to part this off to about 3/8 in length, or just about 9.5 millimeters. I'm going to come in with the chamfer tool there just to clean up the edges of that knurl, just to make the thing look nice. And we're almost done with this part. So let's just face this and chamfer the internal diameter there. And it's time to move on to the next part, which is the post boss. And the purpose of this component is to be the interface between the shaft and the base. The shaft is included with the kit, and it's 5/16 drill rod or silver steel, which is just under 8 millimeters. And the first job is to drill out this boss to just under size so that we can ream it to ensure a good fit between the shaft and the boss. Now, if you wanted to swap this for a metric size, I'm sure you could do that, no problem, but you would have to then supply your own drill rod. And now that's done, we need to turn down the OD of the boss to fit the 7/16 bore that we created in the base earlier on. Now this is the other component in the project that we need to make sure that we get right if we're going to ensure that the final tool is going to be square. And there are two surfaces on this component that matter, and one is the shaft that we've just turned, and the other is the face that we're cutting now. And these are going to interface with the features on the base that we machined earlier on. And as we've turned both of these surfaces in the same setup, in theory, they should be perfectly perpendicular to each other. And the other important feature here is quite a subtle one, but it's this undercut that I'm putting in right now. And what that's going to allow us to do is to avoid any kind of fillet in the corner of that boss there that's going to interfere with the fit of the base later on. And in terms of the main turning work on this part, we're pretty much done. I'm just going to put a nice little chamfer on the end and also on the rim, and we can crack on with the single point threading that we need to do. I'll be single point threading this 7/16 by 32 TPI as per the plans, but if, as I said earlier, you've chosen to go with a metric thread on the locking nut, you'll need to do the matching thread on this boss. So I've just done a scratch pass there, and I'm now checking it with the threading gauge, and I think we're looking good. Time for parting off now, and we'll come in with the chamfer tool there and just tidy up those edges before finishing the parting operation, and then we're good to turn the part around and just finish that top face. So the last job on this part is just to clean up that parted face and to chamfer that internal diameter, and that's our part finished. Like I said earlier, the main shaft is made from 5/16 drill rod or silver steel, which is supplied with the kit and is on dimension. So we don't need to turn this. We just need to clean the ends up. So we're going to do one end, we're going to dome one end with the file, and we'll clean the other end up with a turning tool. And just polish everything up with a bit of Scotch-Brite. The final job to complete this shaft is to glue it together along with the boss that we made earlier, and for this I'm going to be using Loctite 648. I think this is the bearing retainer compound. Anyway, it's pretty strong stuff. The only way you're ever going to get this apart really is by heating it up, otherwise it's going to be pretty much a permanent bond. And now we're going to put the components for the base together, and as I said earlier, the really important thing with this tool is that we maintain squareness between the base and the shaft. And because we cut this shoulder and this diameter here in the same setup, we can be pretty confident that they're going to be square to one another. And the same can be said for this face here and the bore of the base, so that when we bring these two components together, we should, in theory, have a square tool. And because that bore is reamed, we get quite a nice positive fit between the parts. And once the locking nut is fitted, the whole assembly is pulled tight together, and that is our base complete. Now I'm going to make these two knife holders, and because they're quite short, we're going to have trouble holding on to these. So I'm going to make one at each end of this bar stock. That allows us to, to have a little bit more material to hold on to whilst we're machining each of the parts. These two parts have a nominal diameter of 1/2 inch, or just over 12 millimeters, and we're going to use 1/2 inch bar stock for this. So we don't need to reduce the diameter of the bar stock any, just need to face off the end. The next job is to put a cone on the end. So we're going to turn the compound slide around to 22 degrees and lock that off. And I'm cutting the cone with a boring tool on the back side of the workpiece, running the lathe in reverse. The material that we get from the knife blades in the kit is tool steel, and it's 3/32 thick, which is approximately 2.4 millimeters. So I want to make sure that the end of the cone is about the same, because we're going to be cutting a slot in this in a minute, and I'd like the cone to come to a point on the knife blade. The surface finish I'm getting in this mild steel with these inserts that I'm using isn't brilliant, so I'm going to clean it up with some emery paper and some Scotch-Brite. This is a decorative piece as much as a functional piece, so I would like it to look nice. I'm done with the cone on that end for now, so I'm going to flip it round and do the other end. So this is where we are so far, and the next job is to cut the slots and the holes for the shaft. So I'm going to take it over to the mill and we'll get set up for that. I'm using an ER40 collet block here to hold the part in the mill vise. And of course, the first thing we need to do is use the edge finder to locate the sides and the end of the part, so that we can accurately find the center line of the part and also reference the drilling positions from the end of the cone. At this point, the more observant among you may have noticed that something's missing from this setup. And yes, that did move. So, like an idiot, I've forgotten to add any support for this. So we need to go back and rescue this situation now. And I've added a screw jack and a small block of aluminium there, just to give us enough clearance for the drill when we break through. And that seems to have done the trick. It was a bit of a pain relocating that hole, but because that was only the pilot hole and I was going to use a bigger drill afterwards, it actually ended up not being too much of a problem. I drilled the hole slightly undersized so that we can get a 5/16 reamer in there. That's just over 11 millimeters, and it matches the shaft diameter for the silver steel exactly. So should get a nice close fit on this part. The next feature that we need to machine is the slot for the knife blade, and that's at 90 degrees to the axis of the hole. So this is the nice thing about using collet blocks in the mill. It's easy to just index the part around by 90 degrees. The slightly more challenging thing is working out how to locate this saw blade exactly on the centre line of the part. And the way that I've decided to tackle this is to wind the head down manually and then use a feeler gauge underneath the saw blade, between the saw blade and the part, to locate it on the top edge of the part. I'll then zero the DRO and move the saw blade underneath the part and use the same method to find the lower edge of the part. And then I use the half function on the DRO to find the midway point. Once I've touched off, it's just a question of zeroing out the DRO and then plunging 17/30 seconds, which is about 13.5 millimeters, into the workpiece to form the slot. Now that's done, I'm going to flip the part round and do exactly the same on the other end. Deburring small, awkwardly shaped parts like this can be a bit of a challenge sometimes. So what I'm using here is a ruby stone that I found on eBay. It's a bit fine for the job, but it's certainly the right shape and is a little bit more convenient than trying to do this with needle files. Now we're back over at the lathe and we need to part off each of the parts from the bar, and to finish the end and then drill and tap for M5. So that's our knife holders finished, and the next job is to make the brass thumb screws that will screw into the back of the knife holders and secure them to the main shaft of the tool. I'll be making these thumb screws out of brass bar stock that you get with the kit. It's 1/2 inch in diameter, just over 12mm, and the first job is to knurl it. We then turn down the main shaft of the screw and thread it M5 so that it will fit into the M5 thread of the knife holder. So that's the thumb screws finished and the knife holders finished. We just need to make the blades for the knife now. But before we do that, I can't resist but to try the knife holders on the shaft there to see how they fit. And I couldn't be happier. They slide on really nice. There's absolutely no play, and they lock with very light torque on the thumb screw. The kit came with this tool steel to make the knife blades from, and we need to get both blades from this one piece, which is going to be tricky because there's not a lot of excess stock there. There's a 22-degree angle on the knife blade, so I'm gonna get my protractor and set that to 22 degrees, and then lay out the cut line on the stock. I've set the stock up in the vise with the cut line as vertical as I possibly can. I was a bit sceptical about this working as it's tool steel and such an acute angle, but it seems to be working just fine. And that has come out a bit rough and ready, but it gives us something to start with. And I'm just going to get these cleaned up, and then I'm going to glue them together with some Loctite so that we can mill them both at the same time. I need to set these up at an angle of 22 degrees in the mill, and the way I plan on doing that is by using these angle blocks. I'm using a 20 degree there and a 2 degree, and that then, as you can see, leaves the top surface being parallel with the mill. One problem that I do have is that these pieces are thinner than the angle blocks, so therefore I'm not going to be able to clamp them in the vise. So the solution that I've come up with is to chock them with a little piece of brass welding rod there, so that I can actually clamp it. As you can see from here, that edge is quite sharp on the point there, so I'm just going to round that off with some sandpaper. I haven't taken much off, but it should just be a little bit more durable. There's another feature that we need to put into the bottom of the blades here, and that's a small recess. I'm not quite sure what the purpose of this is. I think it's probably just cosmetic, but it's on the plan, so I'm going to do it anyway. So the first thing to do is to find the end with the edge finder, and then simply to mill down 1/32, which is about 0.8 of a millimetre, with a 12mm end mill. And then the final job to complete these two parts is to bring them to length. And after a bit of clean up, that's our knife blades finished and ready for heat treatment. I'll be using my oxyacetylene torch setup here today to heat treat these parts, and then I'm going to be quenching them in plain water. I've heat treated both parts and now I want to temper them, and it's a little difficult to see on the video here, the lighting's not very good, but I'm heating the part from one end using a blowtorch, and I'm just waiting for that colour to start changing. And here it goes. You can see it starting to change from that kind of straw colour to a blue, and for that colour graduation to start chasing its way down towards the tip of the tool, because I'm heating it from one end. And yeah, we just want to get that straw colour onto the tip. And it might be a little bit easier to see here, but yeah, as the tip of the tool is that straw colour, hopefully that means that we're tempered correctly. And I'm just going to give both the knife blades a quick clean up on some emery cloth just to get rid of the any oxidation. And the final job we need to do is to glue these knife blades into the knife holders. And for that, I'm going to use Loctite 648. Pretty strong stuff. So yeah, that should be a more or less permanent connection. We can always heat it up if we need to take the blades out for sharpening or anything like that. So that is our lathe centre height gauge complete and assembled. Now before I go on to explain how to set up and use this tool, which I shall do shortly, I wanted to talk briefly about the giveaway. I've been so humbled by the support that I've been getting with you guys watching the videos and subscribing to the channel, and yeah, it's just it's blown me away. So I'd like to give something back. So I will be giving this tool away to one of my subscribers. I'm happy to send it anywhere in the world, and all you need to do to enter the competition is to number one, be subscribed to the channel if you're not already, and number two, leave a comment underneath this video saying that you'd like to be entered into the competition. Now let's talk about how to set up this lathe centre height gauge for use. I'm going to show you 3 different ways to set the tool up, each with increasing levels of accuracy. Now the first one's a quick and dirty method. We simply put a dead centre into the tailstock and offer the tool up to it, and adjust the height of the tool until the points meet. Now the advantage of this method is that it's super quick, and I generally find it's accurate enough to get you in the right ballpark for setting lathe tooling to centre height. What it doesn't count for though is any wear or run out on your tailstock. So if you want a bit more accuracy, then the best thing to do is to machine a taper to a point in your headstock. Now this method should be good enough for 99% of jobs, especially setting lathe tooling. But if you wanted to, for instance, use this tool as a scriber, then there is one other technique to up the accuracy further still. And we start by facing off a piece of stock in the chuck. Now the bigger the stock, the better really for this. I'm using stock that's about 40mm, and we'll glue this up with some die cam. Then we take our height gauge and we scribe a line across the face of the work before flipping the work 180 degrees and scribing another line. Now if these lines don't meet exactly in the centre, then we know that our height gauge is off centre. Now if you don't have an accurate way of indexing the head of your lathe around, then these lines often will turn out non-parallel. You can measure the distance between these lines to work out the error, but one thing to bear in mind is that it's going to be 1/4 of the distance between the lines, not 1/2 as you might expect. But what I tend to do generally is just to move the head by trial and error until I get the thing lined up. And there you can see we're perfectly on centre. So now that we have our centre height gauge set up, we can use it to set up our tooling. So the way I do this is I start with the lathe tooling a little bit too low so that I can sweep over the top of the cutting surface with the tool. And then I gradually raise the height of the tool until it contacts on the end of the tool, which means I'm just a tad too high. And what I then do is then I back the tool off and just lower it very slightly, and it means I'm pretty much bang on centre height. So that was another really fun little project. If you'd like to build one of these yourself, you can buy the kit from Hemingway Kits. I'll leave a link in the description. So that's pretty much all we have time for this week, folks. Thank you very much for watching. If you want to support the channel, then please do drop me a like and a subscribe and a comment below, and you never know, I might be sending you this tool. Thanks for watching, and I hope to see you next time.